Hello everybody, happy Tuesday. Our target today is to convert the moles and particles of a substance. So by the end of this video, you should have gained some experience with converting moles to particles, as well as converting particles to moles. All right, so how do we do that? Well, it just so happens there's a really handy dandy equation. Let's just say, for example, we know how many moles of a substance we have, but we want to figure out how many particles of a substance we have. We're going to use something known as dimensional analysis in order to figure that out. So we simply take the number of moles and we use a conversion factor to tell us how many particles we have. Okay, so what conversion factor do we use? Well, if you guys can recall from yesterday, we talked about something known as Avogadro's number, which is 6.02 times 10 to the 23rd particles in 1 mole. So what I can do is I can use that ratio of numbers to help figure out the number of particles. If I use my ratio, I can have 1 mole be on the bottom, and I can have Avogadro's number in particles, which I will abbreviate as part, on the top. Okay, let's talk a little bit about why 1 mole is on the bottom and why my particles are on the top. My moles are on the bottom because I need the number of moles that I have to cancel out so that my final unit is the number of particles. Okay, why did I use these particular numbers? Because I'm effectively multiplying the number of moles by 1. See, 6.02 times 10 to the 23rd particles is 1 mole. And so in math, it's okay to multiply something by 1. And since these are effectively the same thing, just with different units, that's okay. Let's try a practice problem to see how this actually works in practice. So let's just say, for example, we have 3 moles of H2O. What we can do is we can use Avogadro's number, which is 6.02 times 10 to the 23rd particles, and we're going to divide that by 1 mole because there is 1 mole in 6.02 times 10 to the 23rd particles. These equal each other. They are the same number. It's like saying there are 12 inches in 1 foot. The numerical value, 12 and 1, are different, but they equal the same amount because they have different units. It's the same thing here. Okay, so our moles are going to cancel out, and we're going to multiply 3 times 6.02 times 10 to the 23rd to get our answer, which would be 1.806 times 10 to the 24th particles of H2O. Bada bing, bada boom. That's how we do it. So here's my challenge for you, is can you do it in reverse? If I gave you the number of particles of something, could you convert that into moles? Okay, folks, so let's kind of go over this problem a little bit. We, in an example, know how many particles we have, but we want to know how many moles we have. So how do we do that? How do we convert the number of particles into the number of moles? Remember, there are 6.02 times 10 to the 23rd particles in 1 mole. They equal the same thing. So which of these numbers should go on the top and which of these numbers should go on the bottom? Take a minute, try and figure out which is which, and more importantly, try and figure out why. And when you think you have the answer, you can start up the video again. Okay, let's see if you're right. So, what I'm going to do is I would put 6.02 times 10 to the 23rd particles on the bottom, and I would put 1 mole on the top. The reason I'm doing it differently from last time is because my particles need to cancel out so that I'm left with units of moles. And it's okay to do this because these two numbers equal each other because they have different units. Cool. I'm going to give you guys a practice problem to try using this setup, and we'll see if you get it. Let's just say, for example, we had, I don't know, 12.04, shoot, hang on. We're going to have to cut this out of the video because I didn't have my example prepped on the screen. There we go. Three, two, one, go. So in this example problem, let's say we've got 1.68 times 10 to the 24th particles of NaCl. Go ahead and see if you can convert this number of particles into moles of NaCl. When you're ready, you can start up the video again and see if you're right. Okay, let's see if you're right. So what we're going to do is we're going to take the number of particles that we have and we're going to multiply it by our conversion factor, just like it says in this little table right here. 1 mole will go on top, and 6.02 times 10 to the 23rd particles goes on the bottom. Our particles cancel out, and we get our answer by multiplying 1.68 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. One big mistake that people make is that when they're punching the numbers into their calculator, the calculator doesn't do their order of operations correctly. An easy way to fix that mistake is to simply put any number written in scientific notation in parentheses so that your calculator is forced to do the order of operations correctly. Okay. So we'll take 1.68 times 10 to the 24th divided by 6.02 times 10 to the 23rd, and you should get 2.79 moles of NaCl. Cool. I'll post a couple of practice problems on the Google Classroom page. Go ahead and give those a shot. See if you get them right. Good luck. Talk to you more tomorrow. Bye.